Oh, hi, welcome to the Calculus 3 lecture series, and we are in the unit of the partial derivatives. And this is our last topic in the partial derivative units, is the lecture number 8. We're going to talk about the Lagrange multiplier. And for the previous video, we did 2 problems. And so this video will continue to working on the remaining problems for this lecture series. Okay, so let me go ahead to go to my next problem from my worksheets here. Okay, so in here, all right, so let's take a look. So the previous one we finished the problem number 2 here, right? So the problem number 2 basically just show us how to, how to set the system of equation. Okay, so problem number 3 here. Let's take a look. Find the volume of the largest rectangular box in the first octane with the 3 faces in the coordinate planes and 1 vertex in the plane, 3x plus y plus 2z equal to 12. Okay, so now let's set it up here, right? So we want to find the largest volume. So the volumes here will be what? X times y times z, right? And so what is my, so this is a function. So what is my constraints? So it's subject to what? 3x plus y plus 2z equal to 12 here. So we use the Lagrange multiplier. Okay, so we say del v, so will be what here? Del v will be the fx, so it's yz, f of y is xz, and f of z is xy here, right? And then the subject to, this is my condition. So let me call these functions here. I call this is g, the x, y, z here, right? So now I know that del g's here will be f g of x is 3, g of the y is 1, g of the z is 2. Okay, so now the Lagrange multiplier, so we say del v is equal to the lambda del g's here. So del v is yz and xz, xy, and equal to the lambda 3, 1, 2. Okay, so I'm going to expand that out. I'm going to use the next page as the, so we can do that. So the first equations here. Okay, so the first equations we have yz equal to 3 lambda. And the second equations here, we have xz equal to lambda. Third equations here, I have xy to the what? 2 lambda. And so we still have what is here? We have our fourth equations, right? So our fourth equation is what? We have 3x plus y plus 2z equal to 12. So see here the lambda x, y, z, right? So 4 variables with 4 equations. We can solve this. The reason why I like to do this problem here, because in here, there's kind of the special tricks here. So this, you see here, this is yz, xz, and like the xy's, right? So the typical would say, okay, so let's try to do here. I multiplied x, y, z respectively. What's that mean? Okay, so like for the here, the first one's here, right? Because it's yz here, I'm missing an x, so I times x here. So I said xyz is equal to what? 3 lambda x, okay? And then the same thing, the xz, what I'm missing here? I'm missing what? I'm missing y's, right? So I will need to times y's here. And then in here, x, y, z, So what I have here, I have a lambda y. So the same things here, this is xy. What I'm missing here, I'm missing z's here. So I times z. So this will give me lambda z. That's what they, so here's 2. Okay, so that's why. So this is 2 lambda z's here, right? So that's what the tricks here we have here. You see, there's a kind of, this is a kind of a common trick for we try to solve the Lagranges here. Because they're all equals, right? So I know the 3 lambda x is equal to lambda y is equal to 2 of the lambda what? 2 of the lambda z's here. So, and I know the lambda here cannot be equal to 0. Why? Because if lambda equal to 0, then what I will have x equal to 0, y equal to 0, z equal to 0, right? So I have no volume, so it will be a minimum here. Okay, so because they cannot be equal to 0, then I can, so this is 3 lambda x equal to lambda y equal to the lambda z's, right? Then I can divide by lambda both sides here. So what I have here, I have 3x equal to y equal to what? 2z here. Okay, so 3x equal to y equal to 2z, right? So my conditions here, now I can substitute. So see here, so now I can substitute this one to the equation number 4 here. So I will say here, so this is 3x plus y plus 2z equal to 12. Because 3x equal to y, so this is y plus y. Haha, 2z equal to y, so it's a plus y equal to what? Equal to 12. So 3y equal to 12, y equal to 4. Okay, so if y equal to 4, right? So y equal to 4, so I know the 3x equal to 4. So what is x here? X is 4 over 3, and the 2z equal to 4. So what is the z's here? Z is 2, right? Okay, so I know I'm going to get the maximum volume of the box, right? Of the box here equal to what? X times y times z. So it's 4/3 times 4 times 2. Okay, so it will give me 32 over 3. That's the biggest volume of the box here. So this problem is kind of quite, it's not hard to solve, right? So if you recognize these tricks here, right? So that's why I mentioned, this is a trick, we need to be careful. And this is quite a common applying tricks here, okay? All right, so now let's take a look at the next ones here. Okay, so the next ones